Good afternoon. How's everybody doing? That good, huh? Nobody responded. So either you can't hear me or you're doing terrible.
I'm doing good. How are you?
Oh, good. I'm doing okay. I'm hanging in there.
Me too. Who is it?
Yeah. Yeah. I mean, there's a lot going on, right?
Mm-hmm.
It's a little busy right now. I'm sure you guys feel the same thing. Since I was just looking and I was like, oh, finals start Monday. Monday. That's crazy. You're like, who would sign up for a final on Monday? That sounds insane. Well, maybe if you want to get it over with, right? That's a possibility. While we're waiting for people, anybody have any questions? Oh, and I was having trouble with the recording from yesterday. It wouldn't press at all, so I have to try it again. I tried it 3 times yesterday, but I don't know. Nobody has any questions yet? I feel like somebody should. Like, why you give us so much homework? Just kidding. You could ask that. I was looking at your oral final exam questions, and I was like, oh, we've covered almost all of them. So you should be pretty good about them, I hope. There's basically when I was looking at it, I was like, maybe 2 that we haven't gone over, super specifically.
Hey, Roxanne.
Yeah.
I have to head out just for like 5 minutes. I'll be right back.
Okay.
Thank you.
I feel like I let someone in and I didn't write it down, but I can't figure out who it is, so we'll figure it out. Like the one I was thinking we haven't covered a whole lot is the one where it's, oh, hold on. I pulled it up so I wouldn't forget it. Write a story problem for multiplying fractions. Yeah, but you should have plenty of examples of those. I mean, we kind of did. Remember when we did our brownie problem? That was multiplication, right? And you have some in your fraction operation homework. You're like, oh, don't bring that up. I hate that homework. Anyone feeling that? It's not that bad. What I really noticed is people don't read directions. So if there's one that you need help on, let me know, because I can help you. I know that there's one really long problem where you have to write out all this stuff, right? You had to fill in like, I don't know, a gazillion blanks, but it's doable. So, and then the other one we really haven't covered is, I think it's a rounding problem. Let me look. Rounding with decimals, right? Oh, it's not rounding. It just says, write the word name and explain how it's constructed. So we haven't really talked about that yet, but I'm pretty sure most of you know that already. But if you have any questions for me, you can let me know, especially if your final is on Monday, right? So, because there are some of you who your final's on Monday. Okay, no questions. You guys are so tired, or you're overwhelmed, or you're eating, or you just, I don't know. What do you think, guys? Karina's like, yes, all of the above. I'm tired, I'm overwhelmed, and I wish I was eating. I don't think you're actually eating. So. Yes, all three, Vanessa. But I didn't see very many of you last night in my office hours. I had some visitors. Who was it? Me and Kelsey, I think. Kelsey and I were working our way through some multiplying fractions visually. What else were we working on? I can't even remember. I don't think we listed the more homework, did we? We listed something else though. I had an online student drop by. Okay. Well, darn it, work. I know, I hate that. So, but remember, you can always just send me a message too. And if we need to meet at another time, we can. Okay. All right. Because I can make you guys a short little video about something if you need it too. Okay. So yesterday, I'm hoping we kind of cleared up some more division. Did you feel good about that? Kind of ish. Okay. A lot of you wrote on your multiplying fractions video assignment that you were like, oh, this video was so nice. Like, it makes sense. It helped me. And then you were stuck on a problem on more that you should have been able to figure out from that video. So make sure you connect all the dots. You know what I mean? Don't do an assignment and be like, perfect, done, mark it off the list. I'm never going to think about that again. Because it probably relates to another assignment somehow, somewhere. Yes? Okay. If you're having a complete panic attack about the final, you should come see me. Yeah? You should not be like, oh, well, guess I'm going to fail. No, that's a bad strategy. Or I guess I'll just meet with my group who is also completely clueless. That's also a bad strategy, right? I mean, it's nice bonding, right? And you can feel good about it. You're like, yeah, we are totally lost. Great. We'll all fail together. No, don't make that your plan. Go ahead and visit with your other people. I'm all about that. You need a support group, right? But hopefully they're helping you in some mathematical way as well. And then you can ask me if you need help too. Yeah, because some of you are meeting today. I've heard that rumor, right? That's totally fine. And some of you are like, wait, who's meeting without me? You guys can schedule your own meetings anytime, right? Like you can do Google Meets anytime you want. Yeah, it's crazy. You don't even have to go somewhere and see somebody in person. You can lay in your bed and do it. Yeah, I mean, be dressed appropriately, right? Don't be a weirdo. Yeah. Okay. Can everybody see my screen? Okay. You know what? Let's do this. Everybody type in the chat the one thing they're most worried about for this final week that we have left, whether it's an oral final exam question, you're just worried about the final in general, whether it's just fraction nightmare, or if it's multiplying fractions, or the more homework is going to make you explode, whatever it is, everybody get it ready in the chat. I'm not judging anybody. I don't care what you put in there. They're going to go by so fast, I don't even care whose name is there. Okay, if you feel like you don't want to share with the whole class, just do it directly to me. But I'm pretty sure everybody else in the class would love to hear if you're frustrated about something. Okay, I'm going to give you 30 seconds to write it in the chat. Oh, you guys didn't want to wait till my 3, 2, 1. You just put them in there. I'm good with that. 3, 2, 1, whatever you're doing, you're good. My good. Some of you are like, I could type here all day, right? We're just complaining, saying what we're worried about. That's perfect. I'm ready for that class. I love, Sarah, that you're saying you're practicing. Oh, I hear you on vocabulary and fractions. Karina, oh, you can get all your homework done before Monday, right? Yeah. Fractions on the oral final. I see that a lot on everybody. Canvas final. I love it when people aren't worried about my oral final, just the Canvas final. remembering all the little things from the first 4 weeks on top of all the new stuff. Here's the good news. Most of it's in there anyway, so you wouldn't even really have to remember it. You know what I mean? It's like all wrapped up into one. Modeling fractions for sure. Elena, I think you just stated everyone's fear, forgetting something important, right? I'm pretty sure that's everyone's fear. You're like, I studied everything, oops, except for that, and that's most of the final, right? But that's not going to happen because you're doing very well on, reading things. Sorry, I don't know, there's like a real loud truck going down my street or something. Visualizing fractions. No, your hard work is not going to go poof. It's not going to happen. You're going to be fine. It's going to be there. Oh, now, Jessica, I feel your pain right there. Finding time this weekend to prepare. Yeah, finding time in general to prepare, right? You're like, okay, what am I supposed to do? Not sleep? Is that the gotcha, right? I hear you. I feel that pain. So really carve out that time, and don't try to do like, oh, I need to study for 8 hours, so I need to find an 8-hour chunk of time, because that's not going to happen, right? So find little bits of time, even 15 minutes of time. Have all your math stuff out somewhere, right? Not where a cat's going to eat it like mine would, but just so it's ready. So when you have that 15 minutes when you're waiting for someone, do it. Anybody have to go pick up anybody anywhere for anything? I have to do that all the time, right? I have to go pick up my daughter from somewhere, and I end up sitting in the parking lot for 10 minutes, right? Waiting. What do you do when you're waiting? Play on your phone, text people, look at TikTok, right? Whatever you're doing. My recommendation is have your math with you. Spend those 10 minutes looking at your math. That can carve out some time, because if you do that, let's say you do that 5 times in a day, which would be easy for me, you've already spent almost an hour studying, right? So carve out those. Now, don't leave your notebook somewhere, right? Don't lose it. That would be terrifying. Okay. Oh, Jessica, I feel that. I getcha. When's your final, Jessica? Is yours Monday?
It's on Tuesday, so I plan to use Monday to also prepare if worst case scenario.
Oh,
I'd rather
good.
have 3 days instead of worst case scenario 1.
Yeah, and your final's not till Tuesday night, so that's good. Okay. All right. So anyone else? Okay, Bethel, now I'm scared. So okay. It's okay. You have time. You can do it. There's not a whole bunch of questions. How many are on the oral final? 10. 10. Right? 10. That's okay. And some of them you'll go, ooh, this one I got. And others of them you'll be like, wait, maybe this one I don't have. Maybe I need to think about this one some more, right? Because some of you tricked yourselves into thinking you knew one on the midterm, and then you met with me and you're like, just kidding, I didn't read that part, right? So be careful. Be careful on that. And it wasn't just one of you, just in case you think I'm talking directly to you. There's a lot of you that happened to. And I'm not laughing because it's funny, but I'm laughing because I can see it on your faces right now. You're like, she was totally calling me out on it. And I'm like, no, I was calling you out on like 10 of you, right? So which practice? Practice for the final. Let me look at it right now, Alyssa, because it shouldn't say it's not available. By the way, I have my screen showing. Is that true? Yeah. So read through that problem while we're sitting here, while I'm looking up this assignment, because that is vital. Oh, okay. I see where it's messed up. Come up with your answer to this question. Okay, come up with your answer to this question. And we'll talk about it in just a minute.
Wait, for the question, is that all just in 1 year? Like the tree grew just 1 meter in 1 year, right?
Okay, follow tree A to tree A. And tree
Yeah, so that's
B
just
to
from
tree B.
2003.
What?
So like tree A from B is just from 2003 and then 2006, right? Like it's
Right,
not,
it just gives you two
okay.
measurements, the measurement in 2003 and the measurement in 2006. Okay, Alyssa, I think that was you who asked that. If you refresh your screen, it should be available now. Check.
It is, thank you.
No problem. I'm glad you said something here because I would never know that. Because from my end, it's like, oh yeah, it's right there. And then unless I go to a super secret place, it doesn't tell me. Okay, does everybody have an answer? Or do you need 30 more seconds? Okay. Why don't we just put in a chat your answer and it can just be a letter, right? You can just say, because it says which tree grew more. So you just put A or B or whatever else you need to put in there. You don't have to have your mathematical justification in the chat. Okay. We'll talk about your mathematical justification. Okay. You ready? 3, 2, 1, go. So this is why I wanted us to put them in the chat. If you notice, if you read down, I'll just read down them. B, B, equally, A, B, A, tie, A, B, both, same. How is that possible? How is it possible that we got all these answers? Doesn't that seem crazy? Here's what that means. Must be a great question. Yeah, must be a very rich question that's going to provide opportunities for discussion. That's what we're looking for here. Okay, so I don't care. So we have 3 camps. We have camp, I think tree A grew more. We have camp, I think tree B grew more. And we have camp, I think they grew the same. Let's start with I grew the same. Not I grew, the trees grew the same. Okay, who wants to defend mathematically their reasoning for why the trees grew the same?
So I think they grew the same because if you read the question carefully, it says which tree grew more, not which one is bigger or which one is shorter. And if you find the difference between the A tree, 5 minus 2 is 3, and then the difference for the B tree, 6 minus 3 is 3. So they grew equally.
So am I writing it correctly up here in the left-hand corner where I said, okay, you did subtraction and you say they grew the same because they both grew 3 meters. Yeah? How many of you in the same camp or the both or the tie camp agree with Karina? That's your justification. All right, there's a lot of you that agree with that. Good. Okay, so how about tree B. Who's in tree B camp? Okay, so anyone in tree B camp, tell me what your mathematical reasoning is.
So I chose B. Originally, like I agree with Karina, like that what she said is definitely true. But I know it's not asking like which one is taller, but which tree grew more. I mean, tree B still did grow more, like it did go taller. So that's kind of how I interpreted it the second time that I read it. I feel like it would be, it's asking for which one like just grew the tallest. So I guess that's kind of my answer.
So if you were going to mathematically justify that, how would you tell me? And anyone on tree B camp can help McKenna out there, because if you're all thinking the same thing, that's fine.
Well, is it just because 6 is greater than 5 compared to A?
So when you're saying it grew more, are you saying from the day it was planted, or are you saying over this time period?
I feel like it could be either. I mean, I don't know now.
I'm just asking, what do you think, Hannah? I know you're going to say something.
Well, I drew it out on a number line. So I was going from the ending where they ended up growing. I see that there's more tick marks for how further they grow. So that's why I chose B. Because I do realize that even though it's flipped, 5 minus 2 is 3, and 6 minus 3 is 3, but there's just more growth. If you,
I think you're missing a jump on your tree A number line. Look at your tree A number line. Do you see how we start at 2 and go to 5?
if you go to 2,
Yeah, doesn't it say tree A starts at 2? So don't you need one more jump there?
I do, yes.
Okay, so does your theory still hold up if now they have the same number of jumps?
Mm. No, it
I'm
doesn't.
just asking. But you were on the same page as McKenna though, right?
Mhm.
Saying like, okay. Anyone else have tree B and they want to add any justification there? I would say if we're talking from when the trees were planted, which I don't know when that is, right? If they were planted at the same time, tree B grew more. I would agree with that disclaimer, right? Because now, if they were planted at the same time, whenever that was, then tree B grew more because now tree B is 6 meters tall and tree A is only 5 meters tall. But if I'm only looking between 2003 and 2006, I'm not sure I can say that tree B grew more during that time period. You see what I mean there? All right, I'm not saying you're wrong. I'm just saying we need to make sure we read all the way through our justification, right? Okay, now let's go to Camp A, Team A.
I picked A, and I said, so for tree B first, tree B started out as 3 meters and it doubled in size to get to 6, but then tree A started out as 2 meters and double of 2 is just 4, so it did more than double. It did 2.5 times its size to get to 5 meters.
Nice. It did more than double. And you said 2.5, right? Times, 2.5 times. How'd you get that? Do you know?
I did 5 meters over 2 meters. So I did the 2006 height over the 2003 height. And that's how I got the double for the tree B also.
Anyone in Amanda's camp? Madison's like, yep. Tristan's, yep. Okay, anyone who is in one of the other camps is like, ooh, I kind of agree with that, even though I still believe mine. I'm not trying to make you not agree with yours anymore. I'm just saying, do you see how other people might have looked at it differently? Yeah. So that's why it's a fun problem, because we could say, oh, they grew the same, 3 meters. Or we could say, tree B's camp is my hardest camp just because I'm not sure I can justify it truthfully if I'm just looking at this picture. I'm not saying it's incorrect. I'm just having trouble with the full justification. And then this tree A growing more, this is somewhat convincing because first of all, I have some mathematics going on there, right? And I do see that tree B is now twice as tall, but tree A is 2.5 times taller than it was, right? So even though tree B is taller, if I'm looking at this time period of growth, tree A is growing at a faster rate. Yeah. Now, some of you look at this one down here and go, not in a million years would I have ever thought of that on my own, right? I live up in this area up here. I live up here. Yeah. How many of you feel like that? Yeah. And some of you are like, I don't even know what you're talking about. I'm still way over here in this town, right? But that's okay. I think even if you started here, you can see the other two ways now, right? You might not have thought of it on your own, but now when you hear other students' ideas, you go, oh, okay. So this brings up additive reasoning versus multiplicative reasoning. So this up here is additive reasoning. This is how most people function. Most of us live in additive reasoning. We just want to subtract the two and say this one's more, so it must be more. This is where I need you to be thinking. Okay, multiplicatively. Not all the time. Sometimes additive reasoning is more appropriate, and we'll talk about that. But multiplicative reasoning is very helpful. If you've ever made a recipe, have any of you ever made a recipe and you needed more than the recipe said, like the recipe only makes for 4 people and you need it for 6 people? Yeah, that idea of what you're doing is multiplicative reasoning. Going, oh, I need 1.5 times my original recipe. That's thinking multiplicatively. If you've ever had someone who doesn't know how to do this on a recipe, it turns out real bad, right? Because they forget to make everything proportional. My son is a classic case of this. He added way too much salt. I was like, what happened? Like, I can barely put this in my mouth without drinking a whole glass of water. And he's like, well, I might have oversalted it. And I'm like, you think? And so we talked about the math that he did. And sure enough, he had like tripled the salt when he was only doing 1.5 times the recipe. Yike. That's a problem. It's definitely a problem when you're baking. Has anyone done that when they're baking? Yeah. And it's super fun when you do it with like baking powder. When you put too much of that in. Or what? What were you going to say?
Don't ever double the recipe when you're baking because it'll never turn out to what you want it to be, because no matter what and no matter how you think you can adjust, it's not going to turn out the same way as if you're doing the single batch. That single batch is that for that reason.
It totally works. I do it all the time. It always works, Tyler. It's usually the math if it doesn't work.
That's fair. I guess I never took this class before too, so.
Well, and you probably do it at Dutch when you're making batches of things.
Kind of. It's more, I try and split 5 flavors into a 1-ounce scoop. That one gets fun.
Yeah. Yeah. So there are practical examples of this, right? There really are. So this is a fun tree problem. Kids get really annoyed with this, right? Because they're like, you just said which tree grew more, implying that there's an answer. And there is an answer, but you can always justify things. Bethel, you're hilarious. Okay, so here's my definitions, additive versus multiplicative. If you're still a little sketch on the tree problem, I have a video in your assignment, in your video assignment on this, about it. And both kinds of reasoning are important and valuable in various contexts. So when we look at additive reasoning, we're just looking at absolute change. We compare using subtraction. When we're looking multiplicatively, we're looking at the relative change. And we compare these quantities with division. Notice it's interesting, it's called additive reasoning, but to find the answer, we subtract. And when we do multiplicative reasoning, to find the answer, we divide. So it's good for us to make these connections between addition and subtraction. Those are inverse operations of each other, and multiplication and division are inverse operations of each other. Okay, so as a math student, it's beneficial for you to be aware of your thinking. Are you thinking additively or multiplicatively? Is it appropriate to do one but not the other? And can both ways of thinking be appropriate? Sometimes yes, sometimes no. Let's talk broomsticks. You're like, what? Broomsticks? What are you talking about? So the red broomstick is 3 feet long, the yellow broomstick is 4 feet long, and the green broomstick is 6 feet long. So if we're comparing the green to the red, we can say the green is 3 feet longer than the red, which would make sense, right? Because we would just say, okay, 6 feet, and this is 3 feet. So additively, we would just subtract them. And now I think you could see multiplicatively, the green is twice as long as the red, right? And that would be that 6 feet divided by 3 feet, and you would get 2, or twice as long. Now, how much longer is the yellow broomstick? The yellow is 4 feet, and the red is 3 feet. So additively, the yellow is 1 foot longer. Multiplicatively, notice that the yellow is 4/3 or 1 1/3 times as long as the red. So I want you to think about that. Do you remember what we did yesterday or 2 days ago with our Cuisinart rods? This is the same idea. So you have a red and a yellow right here, yeah? And we're gonna split these into feet. Let's see, one. I should do the yellow one first because it would be way easier. So 1 foot, 2 foot, 3 feet, and then this is 4 feet. So when I compare the yellow to the red, the yellow, it's 1 1/3. So to copy the red, I would need 1 whole copy of the red. And I would need 1/3 more of the red. Yeah? Again, I would have to add 1 more third of this piece right here. And notice I could just do 4 feet over 3 feet and get that 1 1/3. Okay. See if you can do it with the green compared to the yellow. And then the yellow to the green. Notice I only want you to think multiplicatively. I only want you to think multiplicatively. So try those two. All right, you ready to go over these? Okay, let's look at this first one. Who wants to tell me what goes in that blank for number 3 right there? Oh, don't everybody talk at once.
1.5.
Yeah, 1.5. How many of you got 1.5? Yeah, very nice. So what did you do to get 1.5?
I guess I can explain. So I looked at the green and I saw that it was 6 feet long, and then I looked at the yellow, which was 4, so I did 6/4.
Very nice. And then that's simplified to 3/2, right?
Yeah.
Or 1 1/2. Nice. How about number 4? The yellow broomstick compared to the green broomstick. What would that one be?
Well, I guess I can explain what I did to that one as well.
Sure.
Yellow, the same. I looked at the yellow, which was 4, and then the green, which was 6, and then that reduced to 2/3. So that's what I got for.
Nice. So do you see how it mattered what order we were comparing these in? Yeah. So, and one was the reciprocal of the other. Very nice. We could do another one. I don't think we need to, but here's a question. On these last, whenever we were looking at it multiplicatively, okay, why didn't we mention feet in our answer? Did you notice when I was writing it down, I put my units on there? And you guys would use a word that I would never use, right? But these units simplify or are irrelevant, right? Because I'm just going to say 1.5 times. I'm not going to say 1.5 feet. That doesn't make sense when you're thinking multiplicatively, because you're looking for like a scale factor is what you're looking for. Okay, so we don't put units in there. If that's a good way for you to tell, are you thinking additively or are you thinking multiplicatively? Does it make sense to put units on there? If it makes sense to put units on there, you must be thinking additively, right? If the units don't kind of fit your mathematical thinking, you're probably thinking multiplicatively. Okay, I got a problem I want you guys to try. Here it is. You're going to try it on your own, and then I'm going to put you in your breakout rooms. Sue and Julie were running around a track equally fast. Sue started before Julie. When Sue had run 9 laps, Julie had run 3 laps. How far had Sue run when Julie had run 15 laps? Is this additive, multiplicative, or both? So first, make sure you spend time on step 1, understanding the problem, okay? So I'm going to give you about 3 minutes in here, and then I'm going to put you in your breakout room. All right. So I just put it in the chat, just in case you might lose it, right? Because you don't have it written down when you're in your breakout room. And since I didn't spend my time wisely and put you in your breakout rooms the way I should have, I'm just going to let it put you in there crazy. Yeah. So it's just going to put you in random rooms. I know you're going to have to say hi to a new person. It's going to be crazy for you. And then talk about this. And I'm not going to give you super long, maybe 4 minutes. And then I just want you to come out with some kind of conclusion, like to the question. So first of all, you should have an answer. How far had Sue run? And then you should have an answer to, is this additive, multiplicative, or both? Okay. All right. Copy it from the chat if you need it. Okay. Call me in if you want me to chat with you. Hi, Sarah.
Hi.
Sorry, I don't know why you got kicked out, but I'm just going to leave you here because we only have like 1 more minute.
Okay.
So what did you come up with? Anything on this one yet?
So I'm not sure if I even did it right, but my guess was that for every 3 miles that the other person walks, then the girl walks only 1 mile. So if we use that thinking, Julie had run 15 laps Sue. Oh, I thought of it the other way. Hold on.
No, you're fine. You can keep thinking.
These ones make you think way more than you would think you would have to think for them.
Yes, I have been turning your brains inside out. So they do. They're very thinking problems. And a lot of it is just as soon as we see a word problem, we start having a panic attack.
Yeah, and then it like with the different like reasonings, and then it's like, wait, which one am I supposed to be thinking of right now?
Yeah. Hello, hello. Was that too fast? Hard for me to know. Did it seem too fast? Yeah. Some of you are like, no. Some of you are like, it didn't matter. I was just sitting there anyway. Like snacking. Just kidding. I know. So Sarah got kicked out, so I just left her in with me, and she was saying, these problems make you think more than you think you should have to think about it, right? Yeah, I loved that. So that's perfect. We start twisting things in our head. So who wants to talk me through their idea? It's okay if it's wrong. Let's just talk through it.
All right, I'm feeling confident, kind of. I'll throw it out there. So,
Okay.
at first, I was thinking, just looking at the problem. Thank you, Bethel. Thank you for the encouragement. I was thinking in my mind, I was like, oh, this has to be multiplicative. Maybe we're just finding the rate of, how many laps that Sue does per, 1 lap of Julie's. But then I was like, no, that doesn't really make sense. So then I started to draw a number, number line for both Sue and Julie for their, do you want me to show my picture?
Yeah, please.
Okay. Can you guys see that?
Yeah, and you guys can pin her or put it on speaker view, and then it'll be bigger on your screen. If you don't know how to do that yet, make sure you do. Okay, go ahead.
So I drew, at first I did like little marks where we were given that Sue was at 9 laps and Julie was at 3. And then we want to find out where Sue was if Julie went to 15 laps. And so then Evelyn and I were kind of discussing how we're assuming here that for every 6 laps that Sue does, Julie does, what did I say? Oh, yeah. Oh, Julie is always 6, sorry.
Julie's always 6 laps behind Sue. That's what we said.
That's what I'm trying to say.
Yeah.
So we thought, okay, so she, the difference here from 15 to 3 is 12. So that means she had so that means there's like 12 laps that Sue had to go from 9. And so then I went another 6 to 15 and then another 6 to 21. So then I So my final answer is that Sue was at 21 laps when Julie was at 15.
And so were you thinking additively or multiplicatively?
Additively, because if we were to think multiplicatively, we're really hoping that, I mean, we're thinking kind of logically, because if we were to do it multiplicatively, we got 45 laps. And that's a lot for them to do. I mean, good for them if that was the real, scenario, but we're just thinking logically here.
Like that didn't seem reasonable.
Yeah.
Okay. And Evelyn agrees with you. And who else agrees with that group, Madison and Evelyn? Anyone agree that, what is it, additive reasoning, and that now Sue is at 21 laps? Anyone else agree with that? Tyler, Essay, Alyssa. Okay, very good. McKenna, Amanda. Bethel said she says additive, but she did it differently. How did you do it?
So I did additively, so I don't know if y'all can see it. So I know that Sue did 9 laps in the beginning, and then Julie did 3. And we know that after a while, Julie did 15 laps, and we don't know how many Sue did. And so I just did additively with Julie. So I just, I wanted to find out like how many, I just like minus 15 by 3 to get 12 laps. So Julie did like already 12 laps, I guess. And then I know that Sue started before Julie. And so I just added 9 laps on top of the 12 to get 21 laps. And that's what I
Nice.
did.
Nice. All right. Did anyone start thinking? I know Madison said they started thinking multiplicatively and then they got 45 and it doesn't make any sense. So there's a key in this question that tells you it's additive. Did anyone find it or identify how you would know it has to be additive and not multiplicative?
Is it because we're subtracting like the 3 taken away from 15? So we know that there's going to be 12 laps that we're going to add.
Yeah, that's a nice way to think of it, but there's a key word in the original problem that tells you you better do it additively. Anyone find it? Tristan, did you find it?
I just saw in the chat that Essay wrote equally fast, and that was what I was
Oh,
gonna
yes,
say.
perfect. Then yes, equally fast. As soon as you know they're running at the same rate, you know that one's not running a certain times as fast. For example, if you did it like 9 divided by 3, you would say that, she is running 3 times as fast as Julie, but that's not true because you know they're running equally fast. Yeah, tricky. Okay, you have a homework assignment that looks like this. There's a video on the tree problem. This homework assignment, if it takes you longer than 15 minutes, you're doing it wrong. Come see me, because there's no way it should take you longer than 15 minutes, this particular assignment. This is what it looks like. Yes, look, there's the tree problem. So that'll give you practice to look at the tree problem. So we've already done a fourth of your homework already, right, on this assignment. This first one, Math Club membership, we'll kind of do it together so you can see. So Math Club from 2003 to 2006. So first it had 4 members in it. Now it has 12 members in it. So Math Club grew by, here's our additive reasoning, 12 minus 4. So it grew by 8 members. If I'm counting how many times as many members, then I would do 12 divided by 4. It has 3 times as many members. And you could see that here's 1 copy, 2 copies, 3 copies. Okay? So that might help you to draw some of these pictures. So it's 3 times as many members. Over here, Writers Club, first it had 10 members. Now it has 20 members, right? 5, 10, 15, 20. So it grew by 10 members. Writers Club now has 2 times as many members. So does that make sense? And how you got the 2 times, you just did 20 divided by 10. Okay. So, and then the tree problem's there, but here's the question. Explain your reasoning. So if we were just going to talk about this one, which grew more, the math club or the writers club? Well, either when I look at it additively, I might say the writers club grew more, right? Because the writers club grew by 10 members and the math club only grew by 8 members. If I look at it multiplicatively, I could say math club now has 3 times as many members. Writers club has 2 times as many members. Which one do you think is more indicative of the situation that's happening here? So remember, math club had 4 people to start with. Now it has 12. Writers club had 10 and now it has 20. So which way do you think is more helpful or more indicative to which grew more, the math club or the writers club? Alyssa says math right away.
I agree with Alyssa.
Okay, Vanessa says she agrees. Now, if it's me and I'm the advisor for math club, I'm going to say I just did an amazing job getting the word out, because now math club has 3 times as many. We only had 4 people hanging out together and now we have 12. So yeah, writers club doubled and now it has 20, which they're still going to brag that they're bigger than the math club. But I'm going to say, whatever, I still got 3 times as many members as I had originally. Yeah. So the idea here isn't, it's really to justify your reasoning, to focus on that idea. A real good example that I think makes sense to people is something like this problem, where, and you can make your numbers even nicer if you're working with kids. A lot of people have jobs that pay them per hour, right? So let's say we have these people, one makes $8 an hour, one makes $10 an hour. This example isn't the best. I should change that example and make it better because I like this example. Let's say somebody makes $10 an hour and someone else makes $15 an hour. And they both get $5 raises.
I can't see the second number because, like, thank you.
They both get $5 raises. So now one's making 15 and one's making 20. And if I asked you, who got a bigger raise? Who got the bigger raise? Person, I'll label this person A and this person B.
Person A.
Yeah, person A. What, you should be super mad if you work here, right? That's why when you give raises, you should give percentages instead of dollar amounts, right? Because it would make more sense. It would be more equitable to give a percentage instead of just a flat raise. If you look at this, if you do 15 over 10, right? Then that's the same as 3/2. They make 1.5 times what they made before. Whereas the other person only makes 1 1/3 times what they made. So this person got more of a raise. Yeah, and I think for me, that makes a lot more sense for me to see it in terms of money. Yeah. Okay. Be careful when you're on the back side of this with money, just because you have to think about things. I know you can do the math, but think about how you would do it in the picture. Okay. So now we've done even more of it. So if it takes you more than 15 minutes now, you better come see me. Okay. Okay. The last thing I want to do, because this is going to help you with your homework. You have a foldable that looks like this. Mine, I'll show you mine because mine is, some of you are looking at it and you're like, that don't look like no foldable to me. It looks like a piece of paper. So here it is in my notebook. So I know it's not super clear, but you can see it's folded. Now watch. Ta-da! It's like an accordion. Yeah. So that's how I have it folded. So that's what we do in class if we can actually be in the same room with humans, but we're not allowed. So what I want you to do right now, this will give you a jump start on your homework, is I'm going to put a question. There's the question right there. Hopefully you can see it. And all I want you to do, if you have this paper, you could do the problem right now. If you don't have the paper, just do it anywhere. Do it on your whiteboard. Just don't forget it later. So this is the only, I don't want you to look up how to do it. I just want you to figure out the problem however makes sense to you. Okay, so here's the problem. If John can drive 330 miles in 6 hours, how far will he be able to drive in 18 hours? And I don't just want the answer in this box. I want you to show your work. Yeah. So if John can drive 330 miles in 6 hours, how far will he be able to drive in 18 hours? Show your work. Think about how you're solving it. And I'm going to be real quiet and give you like 4 minutes. Okay. Because I want you to show a lot of work. Label everything precisely. All right, does everybody have an answer? Yes, everybody has one? Okay, now, here's what I want us to do. Someone share with me how you solved it. Okay, you can hold up your board or whatever you need, how you solved it. Tyler.
Okay, I didn't really write it out very big, so it's gonna be small. I did it two different ways. The first way, I wanted to find how much he drove within each hour. So that way I can multiply it by 18 to get the total amount he drove. So to do that, I took 330 miles divided by 6 to get the amount that he drove per hour, which gave me 55 miles per hour. Or if you really want to look at it, his actual speed. From there, I multiplied 55 by 18 and got that he had driven 990 miles in 18 hours.
Nice. And then what was the other way you did it? Do you want to share the other way too?
Yeah, the other way I did it was I actually took the total drive of 18 hours divided by the 6 hours he had already driven to try and find, there was a word I had for it in mind and I totally spaced on it. But basically like the amount of increments he drove in those 6 hour periods. So knowing that he drove 330 miles in 6 hours, multiply that by 3, you get 990 miles as well.
All right. So did anyone do it a different way? There's more ways.
That was a little bit harder, but it still got the same answer as Tyler. I took, my handwriting is horrible right now. You're not gonna be able to see it, so I'm gonna explain. So I got the 55 miles because I divided it as well. And then I just took the 330 and then I added 55 for every hour and I wrote that out for every hour.
Okay, perfect. That sounds good. So it was the same idea as Tyler because you found the 55 miles per hour, but instead of multiplying, you just added.
Yeah, his way was much easier.
Nope, but that's fine. Did you get the right answer?
I did. I got 990.
Then that's all that matters, right? Don't judge your way. That's okay. It's what made sense to you. Did anyone do it differently? Speak up. I know there's somebody out there who did.
I did a number line.
You did a number line.
Yeah. So I did my number line 0 to 18. And then I did a jump every 6 hours. So I got 3 jumps. And I knew the jumps were 330 miles. So I did 330 times 3 to get 990 miles.
Nice. Nice. Any more takers? I know we have more ways out there, Hannah.
I was trying to remember what we did yesterday, and so I don't know how valid this is, but I tried to set up equivalent fractions. So I did 330 miles over 6 hours, because that's what we already knew. And I said equals a certain number of miles over 18 hours. And I was like, I'll just make common denominators, which I did. I multiplied 6 by 3 to get 18, and then 330 times 3 to get 990.
Nice. Am I still sharing my screen?
Yeah.
Okay, good. So I was writing down what Hannah was doing, right? So Hannah, basically you said, how can I make this 6 and 18? Right? So times 3, 990. Well, here's the best thing ever. This always happens. It's better when we're in a live classroom and we can all see each other's papers when we do it, but I'm going to show you. What you guys just described to me was the 3 types of proportional reasoning: scaling, constant multiple, and constant ratio. So how many of you set up a proportion like I just showed and cross multiplied? Did anyone do that? Very nice. That's a perfectly valid way to do it. A lot of people do it that way. Did you set up your proportion just like Hannah did? Okay, good. So that's this way. That's the way most teachers teach to do it, right? Set up a proportion, cross multiply, solve for the missing one. It loses some meaning when you try to label things with units there. So just be careful. I'm not saying not a completely valid, because it is, but it shouldn't be your only way, right? What Tyler first described, Tyler and Alyssa, where they found that unit rate, where they found 55 miles per hour, that's called a constant multiple. Okay, finding how much it takes for one, that's what that is. And that's a great strategy. Some of us naturally do that, right? And then the last one is scaling, which Hannah described. Even though she set up a proportion, that idea right here of scaling, this times 3 times 3, that's a scaling factor. Okay, so it's amazing because we all can get the same answer, but we all think differently when we do it. Okay, so when you do your proportional reasoning homework, it says do it 2 ways, right? And that these are when, so watch the video first, right? There's a video assignment of this to help you with this one, because it'll explain each one of those separately. And then when it says do your proportional reasoning homework, it wants you to do it more than one way. So do it the way you naturally do it and label which way that is. So like Tyler, when you're writing on your foldable, you can say, when you found your unit rate on the left-hand side, that's what you were using, right? So you were using constant multiple. And then on the right-hand side, I can't remember what you did. Oh, you probably did a scale factor on the right-hand side of yours, right? Because you scaled it. And then Hannah, you did scaling. Essie and who else did cross products, right? Because you did constant ratio. So the foldable, that first box is what we just did in class. So identify how you did it naturally. And then the video shows you the other 3 ways to do it. Okay. And once you're aware of all 3 ways and you practice them, you'll notice that sometimes one's easier than another to do. Like Alyssa was saying, boy, my way was a little longer than Tyler's, right? Once you do these a few times, you'll go, I don't know why I kept using cross products when a scale factor was so easy on some of these. Okay.
Well, I have a question.
Yes. Go ahead,
So
Vanessa.
then constant ratio is kind of like the scale factor, or no?
No, they're not. They're done differently.
Ratio is kind of like scaling.
Constant ratio is very specific. Constant ratio is this. Let me show you. You still set up this as a proportion either way, right? But when you do constant ratio, you do this. Whatever that is right there. And you go 18 times 330 divided by 6. If you're doing this mathematics, you're using constant ratio. Hannah set up this proportion, but then did it using scaling. So when she did this idea of times 3, that's what makes it scaling.
Okay, yeah, that's what like confused me for a second when you were going over it, but now it makes a lot more sense. Thank you.
And when Tyler did it a little bit differently. Tyler did it 18 hours over 6 hours equals 330 miles, and he might have had these upside down compared to how I have it, is what here? And he did it this way and said times 3, and so times 3. So that's still scaling though. So it doesn't matter, you can scale numerator to denominator, or you can scale numerator to numerator, denominator to denominator. Nice. It's a little bit different. This is super fun thinking. This is very helpful thinking. Pictures are also great like this. Like who described their number line? Sunita, her number line, right? That idea. Drawing a model is very helpful. Even if you're drawing a model, you can still think of which strategy you're using. So I think Sunita said she had a number line and she said she jumped 6 hours and then 12 hours and then 18 hours. And up here she had 330 miles. right? So that's still scaling. Yeah. Scaling is one we do naturally that we've never thought about why we're doing it before, but we do it a lot. A lot of us do. Okay, now that being said, you have a ton of homework, right? Some of you are crying about all the homework to do, right? We've done a lot. Let's look at this horrible screen right here. Oh, by the way, I have a lot more examples of proportional reasoning. Just go through them if you want. They're all solved for you. Okay. This is a good one. Double number lines might remind you of biking to Bernie. Okay. Let's go here. Okay. This was already due. That should be done. This we did in class. This was already due, so that should be done. This we did in class. Foldable for fraction operations, that's a great way to practice for the test, right? McKenna was asking me about it. That's like your way to study. The video we started already right here. These two are video assignments, so quick. This one is a biggie right here. There's a lot of problems on there and they might be kind of challenging. I'm gonna move that due date to Tuesday, okay? I'm gonna take that off your plate. I'll just move it to Tuesday. You can still do it, but either make sure you have enough time to prep for your final, right? So I'm gonna move that to Tuesday. So I'm gonna write that and then I'm gonna do it right after class because you know I'll forget if I don't. Yay, I love the hearts. You would prefer if I just said, how about I get rid of that assignment, right? Not sure I can do that, right? Okay, and then your more videos, those shouldn't be too terrible. And then the additive versus proportional reasoning, you did have, there's one assignment on here, the more fraction operation that is making you cry. You should always be wary if I gave you 2 weeks to do a more assignment, that it's probably going to be long. Yeah. So let me know. I enabled that button so you can ask your instructor a question if you have any questions. So hopefully we've chewed that up enough to where you don't feel totally overwhelmed with your homework. Yeah? Better? You're like, no, it didn't help me at all. Remember, I moved that one. Okay. Your exit ticket's real short. Let me find it. And then I'm going to stay here and answer questions if you have them. And then I'll be checking my email all weekend if you need anything, because I know you're going to be studying. Let me look at the Jamboard that's due tomorrow. What's the Jamboard that's due tomorrow? Let me look.
That was the one that we did in class that you said we could do it if we wanted extra practice, but you would just give us credit for being there in class.
Yeah, so there you go. Did I not give you credit yet?
No.
Okay, let me find it.
It's the one with the 13 slides, right, Hannah? I think so.
Yes.
Multiplying fractions and mixed numbers, Jamboard classwork, that one?
Yes.
Yeah, I actually already gave you all credit.
Then that must have been my fault, and I just haven't noticed that yet.
Yeah, I gave you all credit, but it is not a fun Jamboard. That would be great studying. It is. It's a really good one. That would be great studying. But you already have credit.
For me, it says that it hasn't been submitted.
Yeah, it says you didn't submit it, but I graded it.
Okay,
You can look at your grade. It's already graded.
thank you.
Yeah. I'm trying to take the pressure off you. Anybody have any questions for me? Yeah, so on each one of those, you need to have a visual and you need to have just a regular algorithmic example.
Okay,
So
that
do
makes-
one with pictures
Okay.
and then do one just normal.
Okay, that is so much easier.
For addition, subtraction, multiplication, and division. And you can make them whatever you want. You can do mixed numbers if you need practice on that. You know, you can make them whatever you want.
Okay, that's a lot more simpler than the
Yeah,
when
I think
was reading directions.
I think I did what you did, Bethel. I did like for all of them.
Okay.
Like for the
What do you mean?
Well, for the multiplying, I did like one by like whole number and then a mixed number one. And then just a regular algorithm.
That's fine, as long as they're all fractions, you're good.
Okay, cool.
Yep, and as long as you make sure you have a visual in there.
Okay.
Right?
Okay, since I did all of them, do I need to add a visual for, well, they're all the same problem, I believe I did.
Well, one's addition, one's subtraction, one's multiplication, and one's division, right?
Okay, yeah.
So you can do the same problem visually and algorithmically if you want. You know, that's totally fine, as long as you have a picture on each one.
Okay.
Yep. Vanessa, any other questions? Okay.
I'm good to go. I will see you next Monday.
Okay, email me if you need anything. I don't want you stressed out. I know you're already stressed.
I've been looking at the oral questions this week. So I started on some of them. So
Yay. Some are more friendly than others, right?
Yeah. I was trying to do like the ones that I feel confident about first. So.
That's a great strategy. That's a great strategy.
Okay, see you Monday.
Okay, bye.
Bye.
Kelsey, you need any?
Yeah, sorry, you're like breaking up, so I turned off my camera. So on the questions for the oral final, number 3, we're going over it, and then you told me to do work first and then come back to you.
Yeah.
Okay.